For decades, we've all had this dream of a truly helpful general purpose robot, right? One that could, I don't know, tidy up the kitchen, grab you a snack, or just understand a simple request without needing to be programmed for every single little thing. Well, that dream has always felt kind of just out of reach. But a recent breakthrough might have just changed everything. We've all seen those robots on factory floors, right? Performing the same task over and over with insane precision. But put that same robot in a kitchen, a messy, unpredictable human environment, and suddenly things get really complicated really fast. This scene right here, this is the ultimate test. It's not just about moving an arm. It's about understanding context, objects, and what we actually want. And that really gets to the core of the problem. We have these incredible AI language models trained on pretty much the entire internet. They get concepts, they can reason, they can plan, but how in the world do you get all of that brilliant abstract knowledge out of the digital world and into the gears and motors of a physical robot?
Yeah, this was the fundamental roadblock. A language model, it thinks in words. It outputs sentences, paragraphs. But a robot? It needs concrete physical commands. Move this joint 30 degrees. Close this gripper with exactly this much force. For the longest time, they were speaking completely different languages.
So the first logical step, which is what researchers tried back around 2022, was to just treat the AI brain and the robot body as two separate things that needed to find a way to communicate. Let's call it the Translator Approach.
So here's how it worked. You give a command, something like clean up the counter. The large language model, the brain, would use its web knowledge to create a plan. Okay, first pick up the bag of chips, then put it in the drawer. Simple enough. But then, a totally separate program had to act as a translator, converting pick up the bag into a long series of low-level motor commands. The robot body would then just execute those commands, almost like a puppet, with zero real understanding of why it was even picking up the chips in the first place.
And this created a huge problem. All of that rich semantic understanding from the internet, what a chip bag is, the concept of tidying up, was totally stuck in the brain. It never ever made its way down to the robot's physical actions. The body was just this dumb machine following orders, completely unable to learn or generalize from the brain's wisdom. But then, researchers at Google DeepMind had this revolutionary idea. What if we could just get rid of the translator entirely? What if the brain and the body could speak the exact same language? This quote from their 2023 paper is the absolute key. And what's so wild about this is just how simple the idea is. They basically said, hey, what if we just treat robot actions, the coordinates, the rotations, the gripper commands, as just another part of the language? Instead of a separate system, what if the command move left was just another word the AI could learn and spit out? And this just brilliantly shows the difference. On the left, you've got the old way, two separate systems with this clumsy translator stuck in the middle. The robot body is totally cut off from all that juicy internet knowledge. But on the right, you have the new, unified model. Now, the brain and body are one. Robot actions are just part of the AI's vocabulary, which lets it learn directly from all the visual and language data it was trained on. Game changer. This groundbreaking concept led to a new model they called Robotic Transformer 2, or RT-2 for short. And it really is the first model that truly thinks in actions. So let's just look at how this actually works. RT-2 takes in an image of the scene and a command from a person. It processes all of this together. And then, and this is the magic part, instead of just outputting text, it outputs a sequence of tokens that represent the robot's next physical action. It is literally generating a sentence where the words are motor commands. It's just one seamless flow from vision and language straight to action. This new architecture is so significant, it actually created an entirely new category, the Vision Language Action Model, or VLA. It's a single unified system where seeing, reasoning, and doing are all completely interconnected. Okay, so what does this actually get us? What's the point? Well, the result is something researchers call emergent skills. Because the robot could now tap into the vast conceptual knowledge of the internet, it just started demonstrating abilities it was never ever specifically trained for. Take a look at this. The robot was never trained on a data set of falling objects. But the language model has read millions of sentences about things falling off of tables. By connecting that abstract concept to its physical actions, RT-2 could understand the command pick the nearly falling bag and actually do it. That is a huge leap in reasoning. And it gets even more impressive. Here, the robot was asked to get a drink for someone who is tired. It wasn't told which drink. Using a kind of chain of thought reasoning it absorbed from all its web data, it correctly identified the energy drink as the best option. Think about that. It connected the abstract concept of tiredness to a specific physical object and action. This is true understanding in action.
So, where does this leave us? Well, this breakthrough fundamentally changes the entire trajectory of general-purpose robotics.
So let's just quickly recap the key takeaways here.
The fundamental breakthrough, the big leap, was unifying everything, treating robot actions as just another word in the AI's language. This created a direct bridge, allowing all that vast conceptual knowledge from the internet to flow right into real-world physical skills. And the result? The emergence of brand new reasoning abilities, letting these robots solve problems they've never seen before. Ultimately, this shifts us away from single-task machines and toward the dream we started with, robots that can genuinely understand and help us in our world.
And that leaves us with a pretty fascinating final thought. This new connection between words and actions means a robot can now learn from our stories, our symbols, our collective knowledge. So the question is no longer if robots can learn to think, but what on earth we will teach them next.